Okay, the last step that I always do um, is set my feeds and speeds for these operations. So we're going to go to the adaptive roughing first, edit. And what's really neat is that Fusion has a feeds and speeds calculator built in for the most part to its system. So some of these fields will automatically adapt when we start changing numbers. And I'm going to explain what all these number changes mean. So first off, spindle speed is how fast the spindle is rotating. And the Tormach has an upper limit of like 5,100 something something. So you can't ever hit that. So the spindle speed, the fastest that we can spin the Tormach is 5,000. Okay, so this is the important number that we're kind of watching, the surface speed. The surface speed of a material is determined by scientists in a lab, and it's on a chart somewhere. And this chart will be part of your notes, but the this surface speed is how quickly you can cut metal at a safe speed. Aluminum is anywhere between 200 and 300 feet per minute. And I'll show you in a different video how they actually calculate this so you can understand it. In this shop environment, now the 200 to 300 feet per minute, the 300 feet per minute is in laboratory conditions with professional equipment, sharpened bits, and tools. That's how fast you should run it. So with aluminum, steel, and most metals, you can always set it down a little lower. So what I'm going to do is I'm going to say, I know that the super speed of aluminum is between 200 and 300. I'm going to type in 250. And what you see that does is that it's turned down my spindle speed significantly. So we're going to keep playing with these numbers until we get something we kind of like. So the cutting feed rate right now is 60 inches per minute. And if in the class you remembered we've been running the 1/8 inch bits at 20, 60 is a bit aggressive for my, it's a bit aggressive for what I like. I'm actually going to run the bits at 30. And I'm going to, because this is a 1/4 inch aluminum bit. I'm going to set 30. And the only feed rate that is different from these usually is the plunge feed rate, which I'm going to set to 15, which is half the speed. Okay, so how do I know that we're getting close to good? This is the part that we haven't talked about before. It all comes down to this little number right here called feed per tooth. And what feed per tooth is, it means how deep of a bite does each tooth, which is the flutes, on the mill, how deep does that bite happen each time? So honestly, wherever you buy your tool from, there should be a chart somewhere that tells you how deep of a bite the tool is prepared to do. For the most part, for bigger tools, you can do somewhere between 0.002 and 0.003. And for smaller tools, you want to do a little bit less than 0.002. For like 16th bits, you probably want it to be like 0.001. You can always take more shallow bites, and your tool will last longer. Now, this is not true for materials that work harden, like stainless steel and titanium, but by the time you're machining stainless steel and titanium, you won't be in this course anymore. That is an advanced metal. The reason you would be careful with all these settings is because if you go too slow, those metals work harden and they become impossible to work with once they do that. So most other metals you can always go slower and you can always take less deep bites. So we're sitting here and the feed per tooth is 0.00261. I'm going to try and knock that down closer to 0.002, and I'm going to try and do that by increasing the spindle speed. 4,000, 4,000. Okay, so we're getting closer because you see it's 0.002. Our surface speed is still within the 200 to 300 range. So let's see what happens if I do 5,000, 5,000, which is the full speed of the Tormach. Now you'll see the reason that I chose 30 is because if I'm spinning at 5,000 and my cutting feed rate is 30, I'm taking bites of 0.002. However, again, all these features kind of jump around. That's now pushed my surface speed above 300, which is definitely where I don't want it. So I'm going to drop the spindle speed to 4,500 and do 4,500. And so the spindle's spinning a little slower in this case because when the spindle spins, the teeth are literally moving at a certain rate in a circle. So this is how dropping the spindle speed drops the surface rate that the bit is dragging against the metal. So at 4,500, my surface speed is less than 300, and my feed per tooth is 0.002. So I can even drop the spindle rate a little bit more, 250 and 250, and you'll see that we're even slower on our feed on our rate right here, and that our tooth is dropping down a little more. Now at this point, I'm kind of happy with these settings, so I'm actually going to drop the cutting feed rate. 28. Oops, that went back. Oh no, that went down. 28. And this is how now the feed rate, the cutting feed rate, the lead-in feed rate, the lead-out feed rate, and the ramp feed rate. Those are how fast the bit is moving sideways while it is spinning like crazy. So you'll notice that by slowing down 2 inches per minute, we've dropped the tooth down to 0.00219608808. Yeah. So I bet you if I drop it down to 27, we're even closer to almost getting 0.002, but we don't want to slow down too much. That's why this is a game of, that's why feeds and speeds are a little bit tricky, and that's why we save them for later, is because you have to kind of balance out all these numbers. So I just adjusted the spindle speed to 4,350. And my tooth is 0.00214 off to etc. So to me that looks like 0.0021, which is very close to 0.002. So I really like that. Now what I'm going to go down here is we have the feed per revolution of the plunge rate, and I do not like that. Every time the bit rotates, it would cut out 0.003. I do not want to do that. So I'm going to downgrade my plunge to about maybe 11. I'm going to downgrade my plunge feed rate, so it's still way below half of these guys, but it's going to be about 2.0025, and that should probably be safe. I will know if that's not safe when I break a bit. So that's why these settings are always so fluid, more or less, is because you can change this, the surface speed, how fast the tooth is cutting the metal, and you can change the feed per tooth, how deep the tooth is cutting into the metal, using a whole variety of different things. So that's the basic lesson. Let's pretend we weren't cutting aluminum. Let's say we were cutting foam. The surface speed of foam is way higher than aluminum. It's almost 500 or 600. So if I typed in 500 or 600, 500, you notice my spindle would have to be going at 8,000. So since our spindle doesn't go to 8,000, what I can do is I can up the feed rate. Let's see, surface speed is 500. See, one of the problems with this is that these things are all linked, so it's kind of tricky to save them. So let's see, 5,000 for spindle speed, ramp spindle speed is 5,000, and then the cutting feed rate is 60. Cutting feed rate is 60, 60, 60. Okay, so yeah, so this, turning this to 60 upped the surface speed. Let's say I turned it to 100 inches per minute. 100, 100. That should be changing this surface speed. Anyway, it looks like these are tied in a way that it'll be more interesting to play with them. I'll make a second video on how to play with them. But for this file, we're going to be doing 4250, and we're going to be doing 4250, and then our cutting feed rate is going to be 30 for the 1/4 inch bit, and then our lead-in feed rate 30, 30, 30, and then our plunge stays at a comfortable 11. And actually, let's do 4,500. Why not? 4,500. Increasing the spindle speed drops the feed per tooth and then we stay within that 300 range. So we will try it at this speed.